Hi, I'm Robin Higgins, and this is an elementary explanation of air density. Okay, so first of all, let's review what density is. Density is defined as mass over volume, which makes sense, right? So let's imagine that we had a brick of styrofoam and a brick of lead. Instinctively, we know that that lead brick is going to weigh a lot more. But in this case, both of these things are the same size. And so the scientific way of expressing that is to say that the lead is more dense than the styrofoam. Little holes for that. All right, so what does air density mean? Well, basically, you can actually take the mass and volume of air. So let's just imagine some, nice park, little tree, the sun shining brightly. And now if you just take a cube of air right from the middle, it will actually have a mass. And so whatever volume it has is just the volume that you measure. And the mass you can actually weigh if you condense all of it. And so even though it's hard to imagine, air is filled with gas particles that we just don't see. I mean, we're breathing oxygen. It's there, we just can't see it. So if we're going to magnify, we could see that our little segment of air from a park has a bunch of molecules in it. And then if you add up how much this molecule weighs plus this, plus this, plus this, plus this, plus this, and all of them, you'll get the mass, and then the length just comes from here. You can calculate the volume. So basically, air density changes a lot, right? Because it depends on different things. So the air density here and the air pressure at sea level is going to be a lot higher than if you're on the top of Mount Everest, right? Mount Everest is a lot higher, so it has less pressure, so the air molecules are going to be more spread apart. And similarly, on a cold day, the air particles aren't going to move that much, they're going to stay lower to the ground than on a hot day when they're going to kind of spread out. So at 15 degrees Celsius, which is pretty cold, at sea level, air density is 1.225 kilograms over meters cubed. And it will completely change just based on day and location. But basically, you just need to get the mass and the volume, and you can calculate your air density. I'm Robin Higgins, and this is an elementary explanation of air density.